Viewers, welcome to the video lecture series on machine learning. Today's topic of discussion is on normalization. This normalization is under the heading data transformation. Before I start discussing the normalization, I would like to first talk on data integration and data transformation. What is data integration and what is data transformation? Data integration involves routines that merges data from multiple sources into a single data set. This may lead to redundant data. The main goal of data integration is to remove redundancy to improve the performance of the algorithm. Normally, when you try to merge data from two different data sets, then definitely there are chances that there may be a redundant data available in the new data set. You have one data set 1, you have another data set 2. When you try to merge these two data sets, then that will result into redundant data because the attribute name may be common in both the data sets, and when you merge, those values are repeatedly appearing in the new data set. So that particular thing you need to remove it, that redundancy. So the main goal of data integration is to remove redundancy to improve the performance of the algorithm. Next, you see data transformation. What is data transformation? It is a process of converting data from one format or structure to another format, often to make it more suitable for analysis, storage, or integration with the other systems. For example, let us say that you have a data set that contains dates in one format, and you need them to be in another format for consistency or for a reporting tool to interpret the data correctly. So suppose the existing format whatever you have is in the form of YY. You need to transform this purchase date into another format, YY format. So first you need to identify the current format, then determine what is the target format, and then apply the transformation. So to apply the transformation, you can use a tool like Excel, Python, or a SQL query also to change the format. Under data transformation is one more topic called as normalization. Normalization is an operation that is used in data transformation. So this is also one of the technique that is used in data transformation. In this technique, the attribute values are scaled to fit in the range 0 to 1 to improve the performance of the algorithm. See, normally when you have a data set, and if whatever is the attribute value, if the attribute values are large in numbers, suppose if you are having an attribute price in the data set and the values are 7,500, 6,000, 9,000, so these numbers you have to bring down to a smaller scale, and that scale is in the range of 0 to 1 only. So let us see what type of methods we can use here in order to transform these values into a smaller scale. See, this is what I just told you now. The primary goal is to bring all the features to a similar and smaller scale, typically between 0 and all the features. Yes, you have several features here. Okay, the attribute names are mentioned here. Under each of these attributes, whatever values you have, there are smaller values and there are bigger values under each of these attributes. So you have to bring all these features to a smaller scale so that performance of the algorithm will improve here, so that the algorithm will deal with the smaller numbers here. There are two types of normalization technique. The first one is the min-max technique and the second one is the Z-score technique. Let us see how do you transform data under the min-max technique. So min-max technique, you have to make use of this formula. Min-max technique is equal to V minus minimum divided by max minus minimum into new max minus new minimum plus new minimum. Well, this is the formula. So what you have to do is, suppose if this is the question, consider the set V equal to 88, 90, 92, 94. So you are having how many numbers here? Let us say these are the marks scored by the student. So there are 4 different values under this attribute: 88, 90, 92, 94. Now in the formula you are having what? V. This V variable is used to represent the marks. So in some of the books you can say VI. So see, you have to scale down to a smaller value, means this 88 has to be mapped to a smaller value, 90, 92, 94. So 4 times you are using here the formula, and each time the value for V will be changing. First time in the place of V you will be using 88, and what is the minimum value here? Minimum is from this range. What is the minimum value? Minimum value is 88. What is the maximum value in this range? the maximum value is how much? It is 94 in the given set, and we have in the formula new max and new minimum also. New max is because you want to bring it to a smaller scale, 0 to 1, so the new minimum is 0 and your new maximum is 1, and here plus new minimum already you have written here, it is 0. So these are the values you need to substitute and find out. So let me just show you the solution here. See, this is what I said. You have extracted from the list minimum 88, maximum 94, new minimum is 0, new maximum is 1. Now substitute in this formula. So first time your V value here, you are calculating for the marks 88. Okay, the remaining things will be the same for all the rest of the computations. Minimum is 88, maximum is 94, minimum is 88, new max is 1, new minimum is 0 and new minimum is 0. Just substitute here. So what you got, it is 0. Next thing is you are going to, you have 4 numbers in the list, no? How many? 4 are there. 88, 90, 92, 94. So for 88 you have just computed, you got 0, and for 90 same thing. Now your V value is 90. The rest of the things remain same and you are getting 0.33. Third time for the marks 92 you will be doing, so your V value is 92, you have got 0.66. The last number in the list is 94, and for 94 when you substitute you are getting 1. So what is the final conclusion? The final conclusion is that it can be observed that the marks 88, 90, 92, 94 are mapped to the new range. The new range is what? 0, 0.33, 0.66 and 1. So 88 is mapped to 0, 90 is mapped to 0.33, 92 is mapped to 0.66 and 94 is mapped to 1. So you can check here, it is in the range of 0 to 1, all the values. This is one of the procedure for normalization. Actually there are several procedures for normalization. The two commonly used techniques or procedures are min-max and z-score. So the one which I have explained now is the min-max procedure. So you can work on this problem also, wherein you can check here there are 4 attributes, 4 features. You apply the min-max technique on this square feet attribute. Square feet attribute is this one. Okay, wherein you can check here the numbers are 1200, 1500, 1000 and 1800. So you have to scale it in the range 0 to 1. So this is all about the min-max procedure in normalization technique. Hope you find this session helpful. Please like, share and subscribe to my channel. Thank you. Bye bye and take care.